All right, let's dive right into this explainer and demystify the incredible 5-step journey your data actually takes every single time you browse the web. When you open your laptop or pull out your phone, the internet feels totally instantaneous. You type something in, hit enter, and boom, the world's knowledge is just sitting right there on your screen. But behind that magic, there is a highly structured, lightning-fast architecture at work. So today, we're going to break down the exact anatomy of a DNS lookup. To kick things off, we really have to ask ourselves how a simple text address magically connects us to servers located all across the globe. Think about it for a second. When you type in a familiar name like Wikipedia, you're using human language. But computers, network switches, those massive fiber optic cables running under our oceans, they don't speak human. They literally only understand numbers. So how on earth does your machine bridge that gap? How does it translate your words into digital coordinates? Here is our quick roadmap for today's explainer. We'll start with names versus numbers, move into the local memory check, look at querying the telecom resolver, cover establishing the connection, and finish up with a technician reality check. Let's get right into it. Part 1. Names versus numbers. Let's set up a really simple metaphor to explain how DNS operates in the real world. Think about your smartphone. When you want to call your friend John, you don't sit there trying to remember his random 10-digit phone number, right? You just open your contacts, tap the name John, and your phone automatically dials the actual number behind the scenes. Well, DNS, the domain name system, is the exact same thing, just for the internet. The website name, like wikipedia.org, is simply a contact name that's easy for our human brains to remember. The IP address, that is the actual numerical phone number the computer needs to dial. Moving right along to part 2, the local memory check. So, keeping that phone book metaphor in mind, let's map out the technical path of a request. It all kicks off with step 1. The user types in an FQDN. Now, I know FQDN sounds like a heavy piece of tech jargon, but it just stands for Fully Qualified Domain Name. Basically, it's the complete, exact text address of the website. When you sit at your keyboard and type www.wikipedia.org, you are submitting an FQDN. And that one simple human action is the catalyst for the entire communication process. But before reaching out to the broader telecom network, your computer does step 2. It checks its own short-term memory to see if it already knows the number. See, your computer has this highly efficient little internal brain called the DNS cache. It essentially asks itself, hey, do we just look up the IP address for Wikipedia like 10 minutes ago? Because if we did, I have the number right here. This internal scan happens in milliseconds and saves a massive amount of unnecessary traffic on the global network. But what happens if you haven't visited this site recently and that cache comes up completely empty? Which brings us to part 3, querying the telecom resolver. Well, if that local cache check fails, step 3 kicks in. Your computer fires off a quick query packet to the ISP DNS resolver. Basically, it physically reaches out of your house or office, sending a tiny data packet across your internet connection straight to your telecom provider's massive server racks. And the message inside that packet is perfectly captured by this thought: I have the name, please give me the number. It's quite literally asking the network's giant directory assistants to find the missing piece of the puzzle. And that takes us to part 4, establishing the connection. So once that query hits the telecom provider's resolver server, it dives into its enormous, globally updated directory, finds the entry for Wikipedia, and immediately shoots back this exact string of numbers, 198.35.26.96. That right there is step 4. The mystery of the text address is totally solved, and your computer finally has the precise digital coordinates of the server it needs to talk to. And finally, in step 5, the browser takes this numerical key, hands it over to the physical network infrastructure, the routers and switches, and unlocks the route. Because these machines finally have the hard numbers they require, they instantly route your web traffic to its final destination. The text disappears, the numbers take over, the connection is made, and bam, the Wikipedia homepage flashes onto your screen. Let's quickly lock this in with a summary of the full 5-step technical path we just traversed. Step 1, user types the FQDN. Step 2, internal DNS cache check. Step 3, ISP resolver query sent out. Step 4, database match returns the IP. And Step 5, successful route via the routers. This exact sequence is happening seamlessly in the background thousands of times a day as you browse. It really is an incredibly elegant dance of data. All right, let's bring it all home with part 5, the technician reality check. Let's apply everything we just learned to a high-stakes scenario that IT pros face literally every day. Imagine you're a field tech. A user is panicking, saying the internet is completely broken because they keep getting a server not found error. Now, an untrained eye might think a fiber cable got cut outside, but you know better. You know routers are unfeeling machines that only care about numbers. So you do check 1. Is the physical line up? You look at the router, the green LEDs are flashing happily. Okay, physical line is good. Then you do check 2. You completely bypass domain names and try to ping a direct IP address, like Google's famous 8.8.8.8. And guess what? The ping goes through successfully. That proves the internet connection is absolutely fine. The data is flowing perfectly. The only thing broken is the DNS translation at step 3. The system just lost its phone book. It is a massive lesson in troubleshooting. If ping works, your issue is 100% DNS. So now that you've mastered the anatomy of a DNS lookup, what deeper mystery you want to explore in our next explainer? Should we cover how to actively clear out that internal brain using the ipconfig flush DNS command? Or should we dive into the complex world of recursive versus iterative queries and see what happens when the telecom provider doesn't actually know the answer either? Think about it, and we'll dive right into that next time.